Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 39, and we're starting Part 1. So we're continuing our investigation in trigonometry. In particular, what Episode 39 is going to be is broken up into several videos on simplifying trig expressions and proving trig identities. That's why this is part 1. And as I said, we're going to be covering several examples. So nothing like just diving right on in. First thing to note about simplifying trig expressions is that we are starting with something kind of complicated or overly complicated, depending on what the problem is. And we are trying to simplify it as much as possible. So we're given here this expression, sine x plus tangent x, that quantity divided by tangent x. Now the directions is simply simplify the trig expression. So to do this, one possible first step to think about is thinking, how can I change this in terms of sines and cosines perhaps? Because I can remember that tangent x is equal to sine x over cosine x. There we go. And so, if we keep that in mind, we can think of this as sine x plus, plus sine x over cosine x divided by cosine x, or sine x over cosine x. So we could do it this way and work it out. Sometimes it works out in our favor to actually break it up in terms of sines and cosines. Sometimes it's detrimental, which is the case here. We'll find out. Now, in this case, we can note that we have this cosine there. In fact, that was kind of hard to see, so let's change our pen setting here. Here we go. Ooh, yeah, that's nice. So, since we have a cosine denominator here, but we do not have one over here, what I'm going to do is multiply this sine term here on the left by a cosine over cosine. That way we get a cosine denominator. We're multiplying by a choice of 1, so it's not fundamentally altering the expression. You have to multiply by some choice of 1, otherwise you are actually altering the expression. That is an invalid operation to do. So without further ado, we get sine x cosine x plus sine x divided by cosine x. And this is all divided by sine x over cosine x. So at this point, what we can do is notice that this is the same thing as sine x cosine x plus sine x divided by cosine x. We have a fraction divided by a fraction here, so there's our numerator. This is our denominator. And so we can take the bottom fraction, take the reciprocal of it, and multiply it to the first fraction. So this is cosine x over sine x. And we can note this cosine is going to kill off this cosine. And so let's keep having fun here. So we get cosine x plus sine x divided by sine x. And notice here that we have a sine and a sine, which means we can factor out a sine. So you get sine x times cosine x plus 1 divided by sine x. And note that the sines kill each other off, leaving you with just cosine x plus 1. And since there's no real way to simplify that further, we'll call that good. Alright. So it worked out in our favor to turn it into sines and cosines, working it out, but notice that took 1, 2, 3, 4, 5. So that was like 6 steps. Alright. Now another way we could have done it is sine x plus tangent x divided by tangent x. We could have thought of it as this: sine x divided by tangent x plus tangent x divided by tangent x. So notice in this case we are breaking up our single fraction in two fractions across this addition sign here. So here the tangents kill each other off, leaving you with a 1. So let's make a note. We have a 1 right here. So we get sine x over tangent x plus 1. And if we wanted to, we could note that 1 over tangent x is the same thing as cotangent x. So this is going to be sine x cotangent x plus 1. And then cotangent x, same thing as cosine x over sine x. So we get sine x cosine x over sine x plus 1, and we get the sines killing each other off. I notice this is sloppy handwriting, so let's scribble that out. Make it obvious, it's a plus 1. Yeah, it gives us our cosine x plus 1. Alright, so there's a couple ways of going about it. So this was 1, 2, 3, 4, 5. Okay, so a little bit shorter. So that's two ways of thinking about this one problem. Let's look at another example. So let's see here. How about this one? Cosine cubed x plus sine squared x cosine x. Now this one looks rather complicated at first because we got these exponents here and here, but don't let that fool you. Instead, focus on the fact that we have cosine terms here and here. This means then we can factor out a cosine, and we get cosine x times quantity of cosine squared x plus sine squared x. Oops, we should make that a parenthesis. And if we recall, sine squared x plus cosine squared x is equal to 1. Therefore, we just get cosine x. So that was relatively easy there. Alright, yeah, we'll do one more example of this. How about, this one looks fun. Maybe, we'll find out. 1 minus sine x plus 1 over 1 plus sine x. Now, here we have a fraction. We have two different fractions here. And since we're interested in combining them, because we want to simplify, combine it into a single expression, we're going to have to multiply by we have to multiply our denominators to get a common denominator. So I'm going to multiply by 1 over sine x over 1 minus sine x. Multiply this 1 plus sine x over 1 plus sine x. So when we do this, the left, we're going to get a 1 plus sine x over, and I'm just going to make a note here that 1 plus sine x times 1 minus sine x. Let's see. I'm going to just note that this is the same thing as 1 minus sine squared x. So this is actually going to be a 1 minus sine squared x. And we have plus 1 minus sine x over 1 minus sine squared x. So we have a common denominator, and so we get 1 plus sine x plus 1 minus sine x. over 1 minus sine squared x. Alright, so we can note that the positive sign and a negative sign kill each other off, leaving you with a 2 over 1 minus sine squared x, and you might be tempted to think this is sufficient, but it is not. So recall that if sine squared x plus cosine squared x is equal to 1, then this means that cosine squared x is equal to 1 minus sine squared x. You see, if we subtract a sine squared x from both sides to this Pythagorean identity, then we get this bottom identity, which is the same thing that we have here. So we can actually rewrite this as 2 divided by cosine squared x. And this is the same thing as 2 secant squared x. And there we are. Alright. Thank you for watching this video. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. In the next video, we are going to start looking at proving trig identities. Alright. Thank you for joining our math party, and I will see you next time.